it tells us the what the component elements in the molecule of the compound, the number of elements there. That is the first thing. The second one is the ratio in which these elements are combined together. The ratio, whether here hydrogen is 2, whether carbon is 1, that is the ratio of combination. And this ratio, we can call it what? Mole ratio. And what is mole ratio? Mole ratio is percentage by mass of elements in that compound over the relative atomic mass. That is what mole ratio. And remember, in my first video, I have taught us how to calculate percentage by mass, and I have also explained how to calculate a molecular formula. So now, this is what empirical formula is all about. The empirical formula will tell us the number of elements, the component elements in the compound, and also it will tell us the ratio of their combination. Now let me now explain what molecular formula means. Gives the exact number of moles of atoms of the component elements in 1 mole of what? The compound. That is what molecular formula. Before you can be able to get this molecular formula, you'll be able to also calculate what? You should be able to calculate what empirical formula. Then you can now be able to calculate molecular formula. Now let me give us an example of how to calculate molecular formula and the empirical formula. I say find the empirical formula of a compound which on analysis yields the following as the reacting mass. Carbon is 2.0 gram, hydrogen 0.34 gram, oxygen equals to 2.67 gram. From your result, find the molecular formula of the compound if the relative molecular mass is 60. Now, I told you that before you can be able to calculate this molecular formula, you can be able to find the empirical formula. You have to first of all find the empirical formula for you to be able to calculate molecular formula, because I said that empirical formula tells us what? The component element and the ratio of their combination. Element, this is element CHO. Then the next one is called mole ratio. Mole ratio is, you now say what now? 2. That is the percentage mass divided by the what now? The atomic mass, which is 12. This is 0.34 divided by 1, and oxygen 2.67 divided by 16. So if you divide this 2 divided by 12, we'll have it as 1.7 approximately, 0.17 approximately. This is 0.34. 2.67 divided by 16. This will give you 0.17 approximately. So now you divide now 2 by divide 2 by the smallest. If you divide 2 by the smallest, you now have what? 0.17 divided by 0.1. You know that 0.17 is the smallest, because this is what now? 0.3. So you divide by that small value. This and this are the same thing by approximation. So you divide. So when you divide this by this, you have 1. When you divide this, this is 1. So let's divide 0 to here is 2, here is still 1. So what am I trying to say now? The first thing you do, you write the elements. Then here is mole ratio, which is the percentage mass over the atomic what? Relative atomic mass. Percentage mass that yielded in that analysis divided by the relative atomic mass. And once you divided and have, you look for the value, the lowest value, use it and divide through. The lowest value here is what? Here and here, they are the lowest value. it happened that we have 0.1710 so we divide both sides. So here now it means that what carbon is 1, hydrogen is 2, and the oxygen is what 1. Therefore, empirical formula now is equals to what now? CO. This is the empirical formula because what hydrogen is 2. So you can see the ratio of their combination. Okay, now let us obtain their what now? Their molecular formula. Because we are looking for molecular formula. What equals to CH2O bracket N. You know that this is that empirical formula. Then, if this is the molecular formula, therefore now we say relative molecular mass will now be equals to, you know that relative molecular mass will be equals to now what? C is 1 here, and the atomic mass of C is what? Carbon is 12. This times this is equals to 12 plus this times this equals to 2 plus 16 all equals to N. So this is equals to N. So we have 30 N. But from the question, the relative molecular mass equals to 60. So we now say 30 N equals to 60. Divide both sides by 30. Therefore, our N equals to what? 2. N is now 2. Open it. C2H4O2 becomes our molecular